Assalamu alaikum wa rahmatullahi wa barakatuhu. And a very good morning to all of you. Student, today our topic is levers. Okay, lever is a rod. Lever means a rod. It is a simplest kind of machines which is used in our daily life. Lever means a rod which is a simplest kinds of machine used in our daily life. What is lever? In your book, page number 51, it is defined as lever is a rigid, straight or bent bar. Bar means just a rod like shape. Okay, bar. Rigid, straight or bent bar which is capable of turning about a fixed point. Which is capable of turning about a fixed point. Okay, this is the definition. A rigid, straight or bent. Either the rod is straight or bent, but it is rigid. Bar which is capable of turning. It can turn or rotate about a fixed point. That fixed point is called fulcrum. That fixed point is a fulcrum. Okay. Now, let's some example of the lever. Seesaw. We will see. Seesaw is a lever. Physical balance is a lever. Nutcracker is a lever. Our door is a lever. Crowbar is a lever. Okay. Even human body, the human arm, human arm is a lever. Sugar tongue is a lever. Fire tongue is a lever. Scissor is a lever. Knife is a lever. Okay, these are some examples of the lever. Okay, now what is fulcrum? Fulcrum is the fixed point where the rod or that rigid body is rotated. The fixed axis about which the lever turns or rotate is called the fulcrum. Here, for example, this is the rod, this is a lever, and this is the fixed point where this rod is rotated. This rod is rotated. For example, this one is a rod. So this is that point is a fixed point. This one is a fixed point. So this one is rotated. Look at this. This one is rotated. So this point is a fixed point. So that point is a fulcrum. Okay. Now, if you put a load here and fulcrum, and this side we are using effort. Okay. So this is the simple lever. Now here are some terms we need to remember. So the distance, this is the fulcrum we put in the middle or between the load and effort. One side load is, another side effort. Put it. Now the distance between load and fulcrum. Distance between load and fulcrum. This is called load arm. This is called load arm. And the distance between effort arm. Distance between fulcrum and effort is called the effort arm. Always the distance between load and fulcrum is a load arm. Whether the fulcrum will be here and load will be here, always the distance between load and fulcrum will be the load arm, and distance between the fulcrum and effort is called the effort arm. Okay, so load arm means the distance from fulcrum to load. Effort arm means distance from fulcrum to effort. Clear? Now the next term is mechanical advantage of a lever. We discuss the mechanical advantage of a machine, that is load by effort here, and I also said that every machine has its own mechanical advantage. Here, look at this. Mechanical advantage of a lever is a different. Now, mechanical advantage of a lever is the ratio of effort arm by the load arm. Ratio of the effort arm. What is effort arm? That distance. That is effort load and distance between load and effort. Distance between load and effort, and load arm means distance between load and fulcrum. Okay. Now mechanical advantage is equal to the ratio of the length of the effort arm to the length of its load arm. Now mechanical advantage will be 1, mechanical advantage will be greater than 1, mechanical advantage will be less than 1. Okay. Now at what condition mechanical advantage will be 1? If these two values are equal. If fulcrum at the middle, what happen? If this is 100 centimeter, what happen? This is 50, this is also 50, then 50 by 50, these are equal, then we have mechanical advantage equal to 1. Okay. But if effort arm is greater than load arm, then mechanical advantage we get greater than 1 value. Okay. And if effort arm is less than the load, it means that if effort arm is less than the load, means load arm is greater, then mechanical advantage will be less than 1. Okay. Now if mechanical advantage is greater than 1, then that condition is called the change in direction of the effort. Mind it, this is very, very important. Mechanical advantage is equal to 1 indicates the change in direction of the effort. Change in direction of the effort. Please do correction, T is missing in your notes. If mechanical advantage is greater than 1, then that condition is called force multiplier. We will discuss what is force multiplier later. Mechanical advantage is less than 1, then that condition is called speed multiplier. Force multiplier means by using small force we can lift a heavy load. That is the force multiplier. Okay, that is the force multiplier. Speed multiplier means that we can save our time, that is, or we can do our time, we can do our work faster. For example, we are using scissor to cut a clothes. Okay, that scissor save our time to cut a cloth, that we are cutting the cloth straight. Okay, straight. But if you are using knife, then the shape of the cloth may be damaged, and that shape will also not cut. Okay, so scissor saves our time, or many other example we will discuss in the second class lever in detail in next video. Just remember this one: mechanical advantage greater than 1, force multiplier, mechanical advantage less than 1, speed multiplier. Okay, here a machine cannot be used as a force multiplier as well as a speed multiplier simultaneously. Mind it, a machine either is a force multiplier or speed multiplier simultaneously. Sorry, a machine cannot be force multiplier and speed multiplier simultaneously. Okay, but a single machine can use as a a machine cannot be used as a force multiplier as well as a speed multiplier simultaneously. At a time, either it is a force multiplier or is a speed multiplier, but it is not at the same time force multiplier or speed multiplier. Mind it, remember this point. Okay, now look at this. Kinds of the lever. There are 3 different kinds of lever: class 1 lever, class 2 lever, class 3 lever. First class lever, second class lever, third class lever. Okay, now remember this term FLE, flee. FLE. F for fulcrum, L for load, A for effort. Okay, now if fulcrum is in the middle, that will be the first class lever. If fulcrum is in the middle between load and effort, that will be the first class. If load is in the middle between the F and E, that is fulcrum and effort, that will be the second class lever. And if effort is in the middle between fulcrum and load, that will be the third class lever. Now VR, that is velocity ratio, and mechanical advantage of the first class lever will be greater than 1, less than 1, and equal to 1. VR and mechanical advantage of first class lever will be greater than 1, less than 1, or equal to 1. It means that the first class lever will be force multiplier, speed multiplier, and also the direction of the effort. Okay, but not simultaneously, mind it. Second class lever, the mechanical advantage and velocity ratio always be greater than 1. The value of mechanical advantage and velocity ratio will always be greater than 1. It means that it is a force multiplier. Second class lever, remember, is a force multiplier. Okay, and why mechanical advantage is greater than 1? Because effort arm is greater than the load arm. The distance between effort and fulcrum is greater than effort. Look at this, fulcrum is here, effort is here. So this distance, and this one is a this is the load arm, and this distance is a effort arm. Look at this, here effort arm is greater than load arm. Okay, here for class 3 lever, mechanical advantage always be less than 1, and VR is always greater than 1. VR always greater than 1. So if mechanical advantage is less than 1, then it is a speed multiplier. It is a speed multiplier. Look at this, why it is less than 1? Here fulcrum, look at the distance between the fulcrum, FE and F and E, fulcrum and effort is less, a small distance, and fulcrum and load arm is a bigger one. Okay, so that's why mechanical advantage is less than 1. So speed, it is a, if the mechanical advantage is less than 1, it's a speed multiplier. So if a question will ask that which one shows speed multiplier, second class lever or third class lever, then the answer will be second class lever. But first class lever also is a speed multiplier. Okay, and it is also the answer will be the third class lever. Okay, speed multiplier is the third class lever, and force multiplier is a second class lever. Okay, example of the first class lever is seesaw, physical balance, pliers, scissors, handles of water pump, that is hand pump, crowbar, spoon used to open lid. These are the examples of first class lever. In human being, nodding of head, human head, nodding of human head is an example of the first class lever. We will discuss these in detail in the next video. Okay, now example of second class lever, bottle opener, nutcracker, wheelbarrow, door. These are the examples of the second class lever. In human being, raising of the weight of the human body on 2 toes, that is the example of the second class lever. Just remember this one, very very important. 2 marks, 3 marks question will given. What is the example of the second, third or first class lever? Now what is the example of the third class lever? Sugar tongue, fire tongues, fishing rod, knife. These are the examples of the third class lever. In human being, the forearm, these arms, the forearm is a third class lever. Okay, so these are the summary of the first, second and third. In the next video we will discuss about the how the seesaw, physical balance, pliers, these levers work. Okay, and these are the main things in human beings: nodding of human head, raising of the human body on toes, our toes, and the forearms of our body. We'll discuss about this one. Okay, now some notes are there. Levers works on which principle? It is works on the principle of moments. Principle of moment. Just remember this one. One question you will ask, that in which principle levers work? Lever works on the principle of moments. Now, clockwise moment of a load about the fulcrum is always equal to the anti-clockwise moment of the effort about the fulcrum. Look at this. This is the load and this is the effort. Here, when load is working in this one, then what happened? Effort are working on this one. Then what happened? This rod will going in this direction and the effort will go in that direction. So this moment is called this is the clockwise, this is anti-clockwise. Okay, so clockwise movement of the load and effort. So clockwise movement of the load about the fulcrum is always equal to the anti-clockwise movement of the fulcrum. Okay, we will discuss this one in the next video in detail. Now remember these things also: mechanical advantage, relation between mechanical advantage, velocity ratio, and efficiency. MA equal to VR into eta. Okay, MA equal to VR into eta. Okay, these things we will discuss in detail in the next video. Okay, hope you understand.